Okay, so now let's turn our attention to the last step, which is removing quantifiers. So let me just start with kind of a generic term like for all x, p of x. And let's say there's some other variables. Okay, so here's what we'll do. We want to prove that something is true for all x, right? So what we have to do is to prove that it's true for any x that you may choose. Okay. Now here's the idea. The choice is made by somebody else, right? So it's kind of like a game. Somebody picks an x, right? And then you have to show that it works for that x. For example, if I am trying to prove that for all x, 2x is equal to x plus x, okay, then you can get to choose the x. And let's say they choose x equals 9. Then it's my responsibility to show that 2 times 9 is equal to 9 plus 9. I'll be able to do that. Let's say that you choose 12. Then I have to show that 2 times 12 is equal to 12 plus 12. Again, I'll be able to do that. Okay. In general, I'm not going to have any control over what you choose. So all I can say is that it's a number. It's a number that's kind of unknown, right? Because it could be any choice. So what I'll do is I'll replace x with a new variable. Okay. So for all x, 2x equals to 2. So let's introduce a new quote variable, okay? Although, to be honest, it's not a variable because it can't change. Nobody uses this term. I do. I call it an unknown constant, okay? And that's just to remind myself that it's not a variable. It's a constant. It cannot change. It can't be anything that I want it to be. It's the number. It's a specific number. I just don't know which one, right? So I may have to prove 2 times some constant. Let's call it c sub x, okay? I like putting c sub x because it reminds me, number one, it's a constant. Number two, it came from for all x. That needs to be equal to c sub x plus c sub x, okay? And if I can prove this, okay, then I've actually proved that this property must hold for any x, right? Because it didn't matter what it was. It just had to be a number, okay? By the way, I do want to note that this is the opposite of what happens when we use a theorem that starts with for all x. In that case, I can actually choose anything, right? But that's because I already proved that it works for all x. So then I can pick any particular x that I need it to work for, okay? Right now, I'm trying to prove that it holds for all x. So I don't get any discretion in the matter. If I choose to prove it for x equals 17, then all I've done is I've proved that it works when x is 17, not when it's an arbitrary number, right? It's this c sub x that makes it arbitrary, right? Because I'm not assuming anything about it. It's just a number, okay? So that's why I do that. Okay, now let's try the other way. What if I want to prove that there exists an x that has some property, okay? P of x. Well, in this case, in order to show that there exists an x that has the property, what I need to do is simply show you the x that has the property, okay? In fact, there could be many x's that have that property, but all I need to do is come up with one, okay? So here I will choose some constant, and this could be either new or old. It doesn't matter, right? I get to pick. That's the great thing here. I'm going to get to pick which constant to use, and replace x with this constant. So let's say that I want to prove there exists an x such that x is greater than 100. Okay, this is a true fact, right? So what am I going to do? Instead of x, I'm going to replace that with some constant. Let's pick 500. Okay. 500 is greater than 100, I'm going to be able to prove that, and then I prove that there exists an x that is greater than 100, okay? This was a good choice, okay? I could have actually tried to prove it with, say, x equals 5, and then I would need to prove that 5 is greater than 100. That's actually not true. I'm not going to be able to do that. That is a bad choice. So in the case of an AND, I actually don't get a choice at all. I just have to pick a new constant, right, an unknown constant, c sub x, and hope for the best, right? In the case of a there exists, I actually get complete choice, so I can choose which x I want to try to prove it for. It's really important to choose a correct value of x, right? So if I'm going to prove that it's greater than 100, 500 is a better choice than 5, right? So that's one of the problems with there exists. That's why there exists are usually harder to prove, right? Because you have to make that choice first and then get it working. And a lot of times in proofs, what you do is you're going to try to figure out the proof so that you can then learn what the correct value of x, right? So you do with the proof and then you go, oh, I needed x to be greater than 30. So go back to the top and say let x equals 40 and then do the proof. Okay. So anyway, so that's one of the secrets of proving there exists.